for those of you maybe don't know me, my name is Andy Turner. I work at EPCC at the University of Edinburgh. I am going to talk this afternoon about our experiences with the ARCHER2 test and development system, which we've had access to for the past wee while now, ahead of the main ARCHER2 system being available. So first of all, the material we used and all that sort of stuff. We've got the usual logo zoo about the partners in the ARCHER2 project. So we've got UKRI, particularly EPSRC and NERC, EPCC, who are looking after the service provision and the computational science engineering, University of Edinburgh providing the hosting, and HPE Cray providing the hardware for the service and some technical expertise to support users as well and support the system. Okay, so what I thought I'd start out with actually, before I got into the meat of the talk about the TDS itself, was a bit about timescales and progress of where we are with ARCHER2 at the moment. So my big caveat here is that although past events are set in stone and can't be moved, the future timescales on this list are subject to change depending on progress and how things go with the system and setting up. ARCHER2 is based on some of the very latest sorts of system and technology from HPE Cray, and as such, and it's one of the first ones in the world of its type. So as such, there's a bit of experimentation and development going on as the system's installed. But essentially, back towards the end of June, the 4-cabinet system passed the factory acceptance tests out in the US and was then shipped. It arrived at the ACF, EPCC's data center in mid-July. And since then, it's been with Cray for fitting and software installation and setup. We're hoping that sometime mid-September, in the next couple of weeks, it will be handed over to EPCC for commissioning into the real service, into a real user service, adding in all the bits and pieces we need to do around user access methods, integration with SAFE, scheduler configurations, installing software, installing research applications. I'll talk a bit more about that later on. With early access for early access users starting hopefully early October, and user service later on towards the end of October is in the current time scale. And then further on in the future, there's the work to take ARCHER1 out of the data center, the larger part of ARCHER2 arriving and being made available to users, going through the same steps that the 4-cabinet system's gone through, and then finally the merging of the 19-cabinet systems and the 4-cabinet systems into the full 23-cabinet system, which is just the ARCHER2 going forwards. Okay, so that's where we are. So at the moment, the 4-cabinet system has arrived and been installed at the ACF and is currently with Cray, with HPE Cray, sorry, and they're working to install the system software and get it up into a state where they can hand it over to us to turn it into a user service. So after the timescales, there are things I wanted to give a bit of an update. I'd just very briefly give you an overview of what the ARCHER2 system and the TDS look like. And we've covered this in previous webinars, so this is not an in-depth dive. It's not detailed information. It's just to set a bit of context. Then I'll go and look at what we've been doing on the TDS and our experiences on the TDS before finishing up with some sort of future look and what can be done, and then hopefully have some questions and happy to answer them. That's the other thing I should have said. Sorry, if you've got any questions on the way through, please ask them in the chat window or using voice. I've got somebody keep an eye on the chat window for me, and they'll interrupt me because I can't see that at the moment with my presentation up, and they'll let me know if there's any questions there, and I'll do my best to answer them as we go along. Okay. So the ARCHER full system, it's a HPE Cray X supercomputer system, formerly known as Shasta when it was Cray before they were acquired by HPE. The peak performance is going to be something around 28 petaflops with almost 6,000 compute nodes and almost 750,000 AMD compute cores. These are all CPU cores. There is a small component of a very small component of AMD GPU coming along with the system. We don't know very much about that yet, and we're still waiting to find out more details about that. But it's not going to be any sort of significant. It's more of a test system where people can try things out rather than a production GPU environment. It's got large work file systems, 4 work file systems, I think up to about 14.5 petabytes of luster. And there's also going to be a solid state. It says here burst buffer, but I think it's more flexible and that can be used in lots of different ways. And some home, a large certain amount of home storage, which is all backed up. And the interconnect is the latest HPE Cray slingshot interconnect, joining up all the compute nodes and out to the storage as well. The compute nodes themselves, which will be obviously doing the majority of the work on the system, are based on AMD's the AMD EPYC processors, which were codenamed Rome. The ones we've got are the 64-core 7742 models. So there's going to be 128 cores per node. There is, I can never remember the AMD term for it, but what on Intel processors we call hyperthreading. There's 2 hyperthreads per physical core, so you can make use of that if your application can take advantage of it. There's just about 5,500 standard nodes, and then almost 300 high memory nodes. The standard nodes have 256 gigabytes, and high memory nodes have twice that, 512 gigabytes. And there are 2 slingshot interfaces onto the interconnect per node, 1 each per socket. Each of those is 100 gigabit per second, so there should be 200 gigabits per second bidirectional per node, and it's into the slingshot network itself. The slingshot interconnect network is an Ethernet-based system, so it's RDMA over converged Ethernet. So it's a different technology, I guess, from InfiniBand, which is what makes up most HPC clusters, and from previous Cray systems, things like Aries and Gemini, and things like that beforehand. So it really is totally new technology for the interconnect in particular, with the ARCHER2 system. The TDS system, the first thing I should say, this is not a photograph of the TDS system. Okay, this is a photograph of the 4-cabinet system in the ACF in Edinburgh when it was being physically installed by the Cray engineers back in July. The blue and red pipes you can see there are coolant pipes onto the compute blades. Anyway, the TDS system itself isn't actually in Edinburgh at all. It's at the moment it's hosted in the HPE Cray factory in the USA in Chippewa Falls. It's a single cabinet system, actually an air-cooled system rather than water-cooled, which is the full compute system, running a pre-release version of the system software, which is known as version 1.2. There are only 8 nodes in the TDS, 4 of which are high memory and 4 of which are standard memory. We've sort of cannibalized the pre and post processing node to use as a login node, and it doesn't have any real any of the sorts of ARCHER2 standard storage connected reason with some sort of local storage solution. In the long term, actually, it's going to be shipped over to the UK. It'll be hosted alongside ARCHER2 itself in Edinburgh, and the TDS will be used to test new software, tools, libraries, and without disrupting the main system, so we can check upgrades and things like that before we go out onto the main system. In the short term, actually, what we're using it for is to get some experience of the ARCHER2 hardware and software, and I'll tell you what we've been doing about that in a moment, before the actual full system arrives. Okay, so thank you, David. Actually, I did hear the chat. I heard a question come through on the chat because it made a little ding noise, so I could switch windows and see what was going on. So AMD used the term SMT. Okay, so that's the sort of vendor neutral term. Right. Okay, so that's the TDS system itself. It's actually very small, and getting access to it is a bit of a pain because you have to go through various VPN hoops and things like that to connect to it in the US. Okay, so our initial priorities or for the TDS access, or the initial priorities for the TDS access, were to allow the HPC systems team here to develop some experience in managing the system, setting things up, where things are and how it can be configured, looking at how we can integrate key systems, so things like LDAP, user authentication, safe, and stuff like that, allowing us to test functionally what's working, how the compilers are working, tools batch system, process thread placements, and all these sorts of things that on this sort of brand new system, with a relatively new processors and a totally new interconnect and totally new setup, how all these sorts of things work to help us develop our experience with the new ARCHER2 hardware, so we're able to support assist users properly when the service goes live, improve and enhance the user documentation. We had some basic stuff in place before we even got access to TDS, but we've been refining that based on TDS access. Look at porting the key application codes in the first instance. We've also done some internal runs of our new introductory training courses to make sure they're fit for purpose, ready, correct, can be improved, or in a fit state for as soon as the service goes live. And of course, before the TDS arrived, we had access to the TDS. We thought it would also be useful to do some performance evaluation and be able to come up with some ideas about what people could expect from applications and how to get the best out of them and things like that. Now, it's not been possible to do that on the TDS, and I'll talk a bit more about that towards the end of my presentation about why that was and how we're going to address that. So what I'm going to talk about in the rest of this talk actually are less the sort of system side stuff, not because it's not important and it's not interesting, but actually because it's not really my thing. I don't really know huge amounts about the system side of stuff, and I wouldn't be able to answer any useful questions, and I'd probably say things that were wrong during my presentation on that. So I'm going to focus on more the sort of application side of things, the more user-facing bits that you'll see. So things like compilers and our experience with the compilers and tools, and our developing experience, and all those sort of things, and go through each of those in a bit more detail, to give you an introduction of what the system, when it comes, will actually look like and how it differs from Archer itself at the moment. Excuse me. So some initial experience and results. So in terms of functional tests, it's actually been really very positive, right? The vast majority of the functionality just works, even though we're on pre-release versions of software. So we tested various compilers. The Cray compiler environment and GCC are already on the system and working well. The AMD compiler toolchain is not yet on there, but it will be on the 4-cabinet system, so we'll check that. We don't anticipate any real problems with the making sure the AMD's compilers are functionally working yet anyway. Various parallel, sorry, it says tools here, that's not quite what I mean. So the parallel libraries and support and programming models have been tested. So in terms of Cray MPT, we looked at the MPI, the Shemen, and the Cray Fortran stuff, and also OpenMP support in the 2 compilers, and checked them and made sure all those are working fine, and they're all working fine as well. Performance and debugging tools. The system comes with a couple of debugging tools, so GDB modified for HPC, and same for Valgrind, which is a memory debugging tool modified for HPC. They both just work fine. There's a few, maybe a few niggly issues, and some things we haven't been able to test exactly, like graphical user interfaces and things like this, because the connection over the VPN over to America, the stability of the connection has not allowed us to export graphics properly in a useful way. But we also tested CrayPat, which is the main profiling tool. And there are various other bits and pieces. Then there are a few sort of little niggly things, but almost all of these we expect to be fixed in the release version of the software, which is version 1.3, which is being installed on the 4-cabinet system at the moment. So another key piece of software for ARCHER2 is the support for containers through Singularity. At the moment, that's not working. We've not been able to test it properly because it requires some configuration on the compute nodes to link to the local user database, the LDAP. Because the LDAP is in Edinburgh and the system is in America, and putting together the sort of University of Edinburgh networks and the HPE Cray networks in the factory, which are obviously the ones particularly are very locked down, has made it very difficult to get the LDAP exported properly to the back-end nodes of the TDS to be able to test the Singularity functionality. But again, that's on the plan for the 4-cabinet system commissioning when that comes live. So we don't hopefully we don't expect any huge issues there, because yeah, it should be fine from what we've seen so far. In terms of the scheduler, one of the big things we wanted to do was get some experience about how the scheduler works and how it controls process placement and thread pinning and all of those sort of things, and how we launch jobs so we can update the documentation and be ready to support the users. So for example, it's going to be Slurm on ARCHER2. If you've come to any of the previous webinars, you'll probably know that. And here's a sort of an example job script from the TDS itself, showing the source of the sort of way you'll be able to sort of where you ask for resources and how they're specified. So generally, you'll end up specifying how many nodes you want. As on Archer, the smallest unit you can request is a full node of 128 cores, and this is a pure MPI job with using all the cores on the node. So this is requesting 4 nodes with 128 cores per node on each of the nodes, and 1 CPU per MPI per process. Okay, we almost always export. Well, when we're not using threading, exporting OMP num threads once to stop any of the underlying libraries expanding and using threading when we're not expecting it. And then you just use srun to launch your application. One difference you'll notice from particularly from Archer and maybe from other systems you used is generally on ARCHER2 you won't specify how many cores you want to launch on with your srun command. And it takes the information required to do that from the options to the scheduler. So I don't know if there's anybody on the webinar who remembers way back to how many national services ago are we now? So we had Archer, Hector. So on HPCX was a bit like this as well. When you had the IBM launch, you specified all the options in the launch options, and then you just issued a command. I think it was POE on HPCX on the IBM system, which then launched using those options. So it's good for those of us who've been around long enough. It's just going back to that sort of model again. Things get a bit more complicated if you're going to use MPI and OpenMP. The options themselves are pretty self-explanatory. They're similar to what you might expect. You know, I select nodes. I'm selecting less tasks per node because I want to make space for my threads with each MPI process, and I want to tell it what the stride is. You know, how many threads are going to be per MPI process. And then, there's a stray capital E escaped there in this job script. And then there's a few extra options to specify about to make sure you get the thread pinning correct as well as the process placement correct. And what I should say is this is one example but there are definitely other ways to do things with more complex placements. So, for example, David, who raised the point before, had a more complex example he was running on the TDS the other day, where he wanted to try and get his MPI processes distributed cyclically across NUMA regions with a block distribution of threads within the NUMA region. You can do those sort of things, and we'll be documenting them in the ARCHER2 user docs to show people how to do more advanced tasks. But actually, it's pretty similar to what we saw for the pure MPI example, is that you specify most of the stuff in the options in the job script, and then just use srun to launch the executable at the end. So a lot of what we've been looking at actually has been working out, you know, how the process and the process placements and thread pinning work in different scenarios, because the nodes themselves have a slightly more complex structure than Archer. You know, on Archer there's 2 processors per node, 2 sockets per node, and they correspond to the NUMA regions. On ARCHER2, each of the sockets has 4 NUMA regions. So there are 8 NUMA regions on their socket, each of them with 16 cores in. So this is why I've chosen this example here, okay, because this is 1 MPI process per NUMA region, and then 16 OpenMP threads within the same NUMA region on the node. Sorry, on the processor. Okay, so that's a bit about the batch stuff, and we've been exploring lots of different combinations there. We've also been working to port various applications across to the system and test that they're all working. So it's been pretty straightforward, as you might expect, given that we can use GCC. I think most of our work is focused on GCC. We've done some work with the Cray compiler, tested it's working, and compiled some applications with it. But most of our porting work has been done with GCC because typically the applications we've had installed on Archer have either been compiled using the Intel compilers or GCC. There's not huge numbers of them that are dependent on the Cray compilers. Though one thing's worth saying is that particularly the new version of the Cray C++ compiler is based on Clang rather than the proprietary Cray compiler technology. So actually, it may be worth exploring, particularly for C++ code, if you've not explored the Cray compiler before. It may be more useful to explore it on ARCHER2 because it's much more standard, because it's Clang based. It should take standard compiler flags and compile as quickly as as the GCC C++ compiler. I mean, one of the problems with the Cray one on Archer is particularly C++. It's lacked support for newer features of C++, and it's very, very slow to compile, which makes development a bit of a pain. That should hopefully they'll be in a different situation on ARCHER2 with the fact that it's Clang based. So we've worked through various applications. So I tried to make up by just looking at where we were this morning, but it's probably out of date for people working on things anyway already. But so far, we discussed we got CastF, codes turn, various web packages, CPTK, GrowMax, some well-used packages. We're still working on some other things. Some of them less, and I've misspelled MetOffice there. There's 2 T's. Sorry, MetOffice UM. There's some widely used applications here, such as the UM, Nemo, and OpenMP that are still work in progress. That's generally not because there's been problems porting them. It's just that there's a finite number of people, and we're just working through things. And as time goes on, they'll just get ticked off as time goes on. We've also started work on evaluating the Cray Python distribution. So, what I don't know if you know or not, but this time the Cray will be distributing their own version, sort of optimized version of Python with some packages provided, things like MPI for Pi, Dask, NumPy linked against the numerical libraries, and SciPy as well. I think there might be something else as well that I can't remember off the top of my head. But what we want to understand is using it and how the functionality works, but also how can you build on top of that distribution. Say you want to build something on top of the MPI for Pi, or you want to compile directly into using the Python headers as part of that distribution. How will that work, and how can we document that and support users doing those things? So we're working on that as well at the moment. A big thing, as I mentioned, is using the TDS to put the draft ARCHER2 documentation in place, and this is up, and you can go and look at it now. It has warnings over it saying this isn't final yet because the system's not there yet. But it's there. You can go and have a look and see where we are with that at the moment. And again, this is going to be refined further once the full cabinet ARCHER2 system's in place with the production version of the system software, which we're going to hope fixes some of the little teething issues we've been seeing, and also there's a few changes to how modules are going to work that's coming in the newer versions of the PEs as well. Now, of course, the system's not live yet, so public contributions probably there's not going to be a huge number of people being able to do that at the moment. But the idea with the documentation is that anybody using Archer and has something useful to add, or can contribute to the documentation if they want to. So the documentation source itself is just on GitHub and a public repository, so you can fork it and issue PRs against it, and they can be reviewed and merged into the main documentation itself. I don't know how many people are going to take advantage of that, but we'll see. It'll be an interesting experiment to see going forward how that works out, and whether we get community contributions or whether it's just going to be the core team contributing. It'd be interesting to see how that works out. But hopefully people can contribute to useful stuff there and make the service better for everybody. That'd be really good. So I'm getting towards the end of my presentation now, so we stop talking soon. So performance, or like I said before, one of the key things we'd hoped to be able to do with the TDS was evaluate the performance and see where we were with that. We've not been able to do this properly on the TDS at the moment because there's actually only one slingshot interface active per node at the moment. We think that'll be sorted out when we get the production release of the software, the version 1.3 that's being worked on the 4-cab system at the moment. And there's been some various issues with power capping of the processors, which meant that we've seen sort of very variable, poor performance across some of the nodes at different times. And what I did think about putting some single node performance results in here, because we do have some data, obviously, because we've tried measuring the performance, but I didn't want to do that because I was unsure how really representative it is of the system going forward, and I didn't think that was fair to either people's expectations or to ARCHER2 itself and the technology itself to share something where we're unsure about how exactly what it represents on the system at the moment. So I think I'll just wait, hopefully another couple of weeks, and we'll have access to the 4-cabinet system with everything working, and we can quickly, we've got the experience of porting, we can quickly get the codes up and running, do some performance evaluations, and then do some sort of update webinar with some performance data from the codes in the relative near future, because I know people will be interested in that. So we're going to revisit this one and see where we get to with that. But yeah, I think the indications are that certainly the performance, the node for node performance for some codes is very, very good, and you know, it depends on how what your code's performance is dependent on exactly what you get out of the systems that compared to other systems such as Archer itself. So finally, I just wanted to give a sum up of where we're going next with the TDS, and then actually more likely with the 4-cabinet system going forward. So there's another picture of the 4-cabinet system being installed at the ACF there before everything's plugged in. So our next steps there, the key thing at the moment is getting the 4-cabinet system commissioned once it's handed over by HPE Cray in the next couple of weeks, and to get that moving forward. So we can repeat the functional tests, check that everything still works fine, install and configure the research software applications for Units as a Service. So these are the central installs of key software. Update the documentation further, and particularly in this time around, we were able to, once we got access to the 4-cabinet system and installed the software and been able to do performance properly, we'll be able to update the application-specific documentation about, you know, how to get, you know, how to use lamps on ARCHER2, or how to use OpenFOAM on ARCHER2, and you know, and how to get the best out of it, hopefully as well, based on the results from our performance evaluation of different applications on the 4-cabinet system, and then hopefully sooner or later release the system to researchers, because I know it's been quite a long road to where we are at the moment, and it sort of feels like the end's in sight, and we can get there. It's still a little bit further off than we would hope at this time, but we really want to get the system released and out and let people start using it and doing their research on it, because that's what it's there for in the end, really. So that's the end of the slides I have. I'm happy to try and answer whatever questions people ask. In some cases, I probably won't be able to answer them, sometimes because I don't know the answer, and sometimes, you know, because things are too uncertain. But I will do my best. I hope you found that useful and interesting. The other thing I can do actually is I can actually show you what the TDS looks like. It's pretty boring, but I should be able to share my application. Just let me stop sharing this one, and hopefully, okay. So this is the TDS itself. Oh, sorry, there was some sort of there was maybe a comment or a question from Chris there. I saw that. Okay, so I know you had the sort of open source documentation approach as well for Isambard, and you've had the odd contribution. We've had the same for Cirrus as well for a while, and we've had some useful contributions for people who are particularly associated with particular software packages that have enhanced the documentation. So I think it's definitely a useful way to go. Okay, so let me go back to the TDS. It's not super exciting, right? You get command prompt and you can list stuff, and there's various bits of software available. If you've ever been on a Cray system before, and this will look pretty familiar actually. You know, there's the various different models, different software products. Sorry. The thing that's new for us, but probably not new for the people that is involved, is these sort of Python stuff down here. Dimitri says, can you include WRF model into the research application test? So obviously, there's there's a finite amount of effort, so we can't look at every particular application. So what we've done, so yes, we'd like to look at other applications, but I think there's an early user access period before the main system goes live. And the idea is that particular user groups have nominated users to get access, and they can get on and test a wider variety of things than the CSE, the actual CSE team they can, because obviously we've only got finite amounts of resource, and there's lots and lots of applications out there that are going to be of interest to people on ARCHER2. So what we've done in the first instance is we've looked at what application usage looks like on Archer across the different research areas, you know, the big research areas that use Archer, and picked out the key applications there to investigate first. You know, if they are done and they're all out of the way and there's more time, then there's potential to start working further down that list. But actually, we'd hope that the early access users would be able to provide a more thorough test by trying out different pieces of software once they get onto the system. How many nodes per cabinet are there? Asks Adrian. 2 cabinets per group, 512 nodes per cabinet then, I think. No, sorry, I'm wrong. 256 nodes per cabinet. I think there's 1,024 nodes in the 4 cabinet system. I think that's right. It's there. But it's organized into 2 cabinet groups in the same way as Archer was, I think, in terms of the. Yeah, okay, thanks. David's done the sum for me there. So the 4 cabinet system works out almost exactly the same size as Archer, or roughly about the same size as Archer itself in terms of core count anyway. Yeah, so there's about, yeah, exactly. So there's about 130,000 cores, and Archer itself's what, around 120,000. So, I mean, of course, there's much more cores per node, so the balance of the system is very different. Sorry, there's many more cores per node, so the balance of the system is quite different in terms of memory bandwidth per core and interconnect availability per core as well. And of course, the NUMA setup of the nodes as well. So the compute nodes are definitely going to be different, and applications are scaled differently on ARCHER2, so it's not exactly equivalent. Yeah, I think one of the racks isn't. I think there is that. Some nodes are for system purposes, and I think one of the racks isn't fully populated as well. So that's why there's not quite as many as you think there are. I suspect that's something to do with cost of system, number of large memory nodes to standard memory nodes, optimize some sort of cost optimization thing there. That it's not exactly an asymmetrical number. And the one thing I didn't say, which I maybe should have said, was that the 4 cabinet system doesn't include any of the high memory nodes. So the first bit that's going to be available to users will only have standard memory nodes available with 256 gigabytes per node. The large memory nodes will come as part of the 19 cabinet system, the 19 cabinet part that ships later in the year. Okay. Any more questions from people? I'll give it a minute, but I mean, on that, thank you for joining. I hope you found it useful, and I'm hoping we'll be back pretty soon with some more data, particularly on performance, which I know people will be interested in. And we'll try and get that turned around as soon as we can once we've got access to the full cabinet system, and get back to people with that. I didn't do the node for node comparison, which I did have in one of our previous webinars, which has a sort of node for node comparison between Archer and Archer2. So if you go back and look at the Archer2 hardware and software webinar with slides, there's some slides there comparing the differences between the Archer nodes and the Archer2 nodes, and where they're sort of up and down in terms of bandwidth, amount of memory, and floating point performance, those sort of things, which people are interested in to be able to find there. Okay, so once again, thank you everybody for joining, and the recording and slides of this will be up shortly, and hopefully we'll see you again at one of the future webinars from Archer2.